Hello students, good morning. I hope you all are safe and healthy at your home. In last lectures, we discussed about anti-tubercular drugs, anti-leprosy drugs, anthelmyletics, and in this lecture, we discuss antiseptic drugs. First of all, we introduce this class. Then after we see synthesis and usefulness of antiseptic drugs. So, first of all, we start with introduction. Antiseptic drugs. The term septic is derived from the Greek word septikos. Please note it there, septikos, which means putrefy or root. Putrefy or root. In medicine, it indicates the state of being infected with pus-forming organisms. Anti-ineffective or anti-infective agents which applied locally, that is applied directly to the skin wound, etc., are known as antiseptic as well as disinfectants. Generally, the term antiseptic include those anti-infective agents which are applied to living tissues. Thus, antiseptics are bacteriostatic and do not necessarily sterilize the surface under treatment. Bacteriostatic, this word we studied in antibacterial drugs or in sulfa drugs. So the antiseptics are bacteriostatic. On the other hand, disinfectants are bactericidal. This definition also we studied in sulfa drugs and anti-tuberculosis drugs. So disinfectants are bactericidal. Antiseptics are bacteriostatic. On other hand, disinfectants are bactericidal, which are applied to non-living surface or inanimate surfaces. They rapidly produce irreversible lethal effects. However, this distinction between antiseptics and disinfectants is a more convention. An antiseptic is a substance which prevents the growth of microorganisms as long as it remains in contact with them, whereas a disinfectant is one which kills the organisms outright. Thus, an antiseptic action is milder but more prolonged, while a disinfectant action is immediate but is of short duration. The ideal antiseptic would destroy bacteria, spores, fungi, viruses, and other infective agents without harming the tissue of the host. However, most of them have limited spectrum of activity and many show an adverse effect on tissues. Hence, the value of antiseptic is greatly affected by their tissue toxicity. The use of antiseptic in medicine is always local because of systemic toxicity which these agents may produce. This prevents other routes of administration which depends on absorption of the body. Here list out some types of antiseptics. The commonly used antiseptics may be classified under the following heads: alcohols and aldehydes. Number 2, aromatic acid and esters. Number 3, oxidizing agents. Number 4, surfactants. Number 5, metal containing antiseptics. Number 6, halogens and halogenated compounds. Number 7, phenols and its derivatives. And number 8, nitrofuran derivatives. So these are the types of antiseptics. We show these types of antiseptics. First of all, alcohol and aldehydes. These are as follows: ethyl alcohol and isopropyl alcohol, carboxide, formaldehyde, paraformaldehyde, glutaraldehyde, formamint, eurotropine, etc. are the alcohols and aldehydes which are used as antiseptic drugs. Now, second, aromatic acid and esters. Both benzoic acid and salicylic acid are bacteriostatic agents. We studied it above also. Benzoic acid and salicylic acid are bacteriostatic. In esters, esters of para-hydroxy and ortho-hydroxy benzoic acid are powerful antiseptic agents. As for example, phenyl salicylate, Salol, and beta-naphthyl salicylate. It is known as Bitol. So Salol and Bitol both are very important antiseptic agent. Mandelic acid is a valuable urinary antiseptic. Today, mandelic acid is used in the urinary treatment. Now, number 3, oxidizing agents. These act as antiseptics. Their disinfectant action is depend on evolution of nascent oxygen. It is noted that nascent oxygen. Example of oxidizing agent which act as antiseptics are hydrogen peroxide, potassium permanganate, sodium perborate, etc. Number 4, surfactants. These possess hydrophobic as well as hydrophilic group. You studied both these words, hydrophobic and hydrophilic, in soap and detergent industry. These get accumulated in the interface and act on bacterial cell membrane that contains lipids. The anionic surfactants, as for example, soap, sodium lauryl sulfate, etc., are antibacterial, mainly against gram-positive bacteria, whereas the cationic surfactants, as for example, benzalkonium chloride, pyridinium chloride, etc., are active against gram positive as well as gram negative bacteria. Number 5, metal containing antiseptics. Mercury compounds are the most important compound among this group of antiseptics. The antibacterial action of this compound is explained based on the basis of their interfering with SH sulfhydral group SH sulfhydral compounds that are essential cellular metabolites. Example of metal containing antiseptics are merbomin, thiomersal, mercurofin, etc. Number 6. Halogens and halogenated compounds. These are known since a long time. The example of these are chloramine T, halazone, dibromomelonuria, vioform, Aristol, etc. are halogens and halogenated compounds used as antiseptics. Number 7. Phenols and its derivatives, commonly called carboic acid. Phenol was introduced by Lister in 1867. Lister, the scientist, which introduced phenol as antiseptic. So, in 1867, as an antiseptic in surgery, phenol was introduced as antiseptic in surgery. It has no specific action. It is therefore called general protoplasmic poison. General protoplasmic poison. Injuring alike the microorganisms and the cells of body tissues. Due to this reason, it is used as a standard against which the potency of other antiseptic were judged. The irritant action of phenol led to the discovery of the more effective and less toxic alkyl and chloro substituted phenols, as for example carbacrol, chlorophenol, chlorometaclazole are the phenolic derivatives which are used in the antiseptic. Number 8 and last, nitrofuran derivatives. Several hundred number of the series have been studied, but at present the following are being used as antiseptics: nitrofuran, archiflavine, methylene blue, phenothiazine, pyridium, etc. are the nitrofuran derivatives which is used as antiseptic today. This is the introduction of antiseptic drugs or antiseptic agents. Now, synthesis. According to our syllabus, we have four antiseptic compounds: chloramine T, halazone, caracrol, and thymol, and one from anthelminetics, that is vioform. So, in this class, we have five compound, and in this lecture, we will synthesize only three: chloramine T, halazone, and carbacrol. Remaining two, thymol and vioform, we will synthesize in next lecture. So, we start synthesis of chloramine T. Chloramine T is synthesized from paratoluene sulfonyl chloride, SO2Cl group is known as sulfonyl chloride. Paratoluene sulfonyl chloride is treated with ammonia. Amination takes place and we get toluene for sulfonamide. SO2Cl is, we describe here, SO2Cl is converted into NH2. So we get toluene for sulfonamide. Now, this toluene 4-sulfonamide is treated with sodium oxychloride NaOCl. NaOCl. We get chloramine. In this reaction, we noted that NH2 SO2 NH2 group is converted into SO2NClNS. With the help of sodium oxychloride NaOCl, we introduce here two elements, chlorine and sodium. It is known as chloramine T. Now, medicinal application of chloramine T. Number 1, it occurs as dihydrate crystalline powder having a faint smell of chlorine. According to smell of chlorine, we identified chloramine T. Number 2, it has appreciable solubility in water and in alcohol. Number 3, it is used as an antiseptic and disinfectant but is less irritant. Number 4, it is applied to mucous membrane as 0.1% aqueous solution and is used to irrigate or dress wound as a 1% solution. It is the very important application or medicinal uses of chloramine T. It is also used as a disinfectant lotion in some infectious disease, as for example scarlet fever, measles, etc. In both these diseases, its lotion is very useful. And last, it is also used in mouthwashes. Today's many of companies use chloramine T as a mouthwashes. This is the medicinal application of chloramine T. Now, second compound is halazone. Halazone is synthesized from paratoluene sulfonamide. Paratoluene sulfonamide SO2NH2 group. We studied about it in sulfa drugs. SO2NH2 sulfamide group. Paratoluene sulfonamide is treated with Na2Cr2O7 in presence of H2SO4. So we get 4-sulfamoyl benzoic acid. Here oxidation process takes place. Our CH3 group is converted into COOH. This 4-sulfomoyl benzoic acid is treated with sodium oxychloride NaOCl. Same reaction as described in chloramine T. Now we get our compound halazone. Here 2 moles of chlorine introduced. Only chlorine introduced from sodium oxychloride, not sodium. So we get SO2NCl2. It is halazone. This is the synthesis of halazone from para-toluene sulfonamide. Its uses or medicinal application: it is a white crystalline powder with chlorine-like odor. It is also identified from chlorine odor. And number 2, sodium salt of halazone is used in sterilizing drinking water. Purification of water is sterilized by halazone. Now, last synthesis of this lecture, caracrol. Caracrol. It is synthesized from paracymene. Here the structure is stated paracymene. This paracymene is treated with concentrated sulfuric acid. Sulfonation unit process takes place. So we get paracumene sulfonic acid. Paracumene sulfonic acid. This paracumene sulfonic acid is treated with fused sodium hydroxide. We get caracrol. And last step, SO3H sulfonic acid group is converted in hydroxy group. So we get caracrol. And last, application or usefulness of caracrol. It is naturally occurring cresol. It is used as antiseptic. Thank you.